Hello, hello, everyone. It's 1 p.m. Eastern, and it's time to begin our special CoCoRaHS Weather Talk webinar on specific weather events of 2025. A very warm welcome to everyone joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is Noah Newman. We're coming to you live from sunny Fort Collins, Colorado. For those of you who are unable to join us for the live broadcast, we're recording today's talk and it will be available later this week on our website. All of our Weather Talk webinars are sponsored by the generous donations from listeners and CoCoRaHS observers. Well, we're excited to have back with us today our old friend Greg Carbon, as we do at the beginning of each year. A little background on Greg. In 2024, he retired to the hills of Vermont after a 31-year career with the National Weather Service. His career spanned local offices in North Carolina, a 20-year stint at the Storm Prediction Center in Norman, and accumulated as Forecast Operations Branch Chief at the Weather Prediction Center in College Park, Maryland. Greg is a longtime National Weather Association member and was awarded the Theodore Fujita Research Achievement Award back in 2016. Upon retirement, Greg founded Vermont Weather and Climate Analytics and now advises the University of Vermont Mesonet program and consults the New York Times meteorology team. Greg, it's always great to have you with us. Thank you for coming back this year.
Oh, my pleasure, Henry, and good to be here to speak today about the events of 2025. Appreciate that invitation, and it's always a pleasure. And I also appreciate all the cooperative observers out there. I've got a steady observation now for a little over almost 2 years in central Vermont, and definitely enjoy putting in the observations daily.
And it's been cold up there, right, Vermont, this year?
Yeah, we've been very cold. It's not gotten above freezing for 20 days.
Wow. Wow.
So it looks like that's going to change coming up.
Great. Well, we'll let you take it away from here.
Okay, let me see if I can get my screen sorted out here. We'll share this one. Let me know if you can see that.
Yeah, that looks great.
Okay. And I'm dealing with a cat here on the desk as well. Typical retirement place with the cat trying to watch the show. She already saw this, but she wants to see it again. So So if you haven't attended one of these presentations before, the rules are pretty simple. These are the memorable weather related events to impact the United States in 2025, mostly chronological order in the presentation. We'll take a deeper dive on some of these events and take a look at the impacts as well. I hope you're having a good start to 2026, and I want to mention my appreciation again for CoCoRaHS observers everywhere. Your data is crucial to our understanding of the weather around us. I'm on my second year of taking daily observations, as I said, for rain and snowfall here in central Vermont, and it's an enjoyable way to participate in citizen science. So I have about 10 memories here I want to share with you today. Should take about 40 minutes to go through these, and there'll be time for some questions at the conclusion of the talk. So let's get underway. So 1 week into the new year of 2025, hot, dry, and windy conditions led to one of the costliest wildfire events in California history. I'm sure we all remember this. On January 7th last year, a series of wildfires started in Southern California, heavily affecting Los Angeles communities. The fire spread rapidly due to an abnormally dry year, coupled with extreme winds ranging up to 100 miles an hour. Two of the fires, the Eaton and Palisades, affected densely populated neighborhoods, spreading rapidly from structure to structure and combining to cause severe damage to over 16,000 homes and businesses. Some pictures shown here show the conflagration at its peak, with a map at the lower right showing the proximity of these huge burn areas to downtown Los Angeles. We'll take a look at the upper level pattern here, basically the jet stream level or mid levels of the atmosphere. The region prior to this event experienced what's called a vegetation trifecta, back-to-back wet winters from 2022-23 and 23-24 caused a surge in vegetation. And then a record dry fall and early winter in 2024 killed off that new growth, turning it into tinder dry fuel. It's not unusual to see these types of conditions out in the West Midwest. And then La Nina further delayed the typical winter rains, ensuring that the landscape was at peak flammability when the winds from the Santa Ana event arrived. A severe flash drought hit Southern California, where they experienced the driest 9-month period on record leading up to the January fires, with virtually no rain since May of 2024. And you can see in the slide here, the upper level pattern evolution featured a progressive and anomalously deep trough forming across Southern California. This is a pattern that's recognized and contributes to higher surface pressure to the east of the higher terrain in California, and then gap winds, which flow through that higher terrain down toward the coastal areas, essentially the Santa Ana winds. Intense downslope gap winds are usually hot and dry and fan the flames of any fires that get started. And some impressively low relative humidity values observed during the onset of the fires here. So anything in the teens for relative humidity means the air is incredibly dry. And I even see a 5% humidity value as a minimum humidity on the map here, not far from where the Palisades fire got started. Just incredibly dry air, and enhanced by that downslope flow that's coming across the mountains from the north and east of the area, essentially the LA basin. And at the peak of the Santa Ana event, these were the peak wind gusts for the 24 hours after the fires started burning. These high winds prohibited the use of fire attack aircraft during the most intense phase of the wildfire, and thus made it very, very difficult to fight these fires as they spread across the landscape. And these winds are just incredible, nearing 100 miles an hour there. And interestingly enough, that 94-mile-an-hour wind speed over the max period of time is just right near Santa Ana. So the winds are well named for the area in which they occur. I'm going to show a video here. Hopefully this comes through on the screen. This is a great a NOAA video of the smoke and fires detected from satellite. We're going to let this run, and it has some annotation on it, so I don't really need to talk during this event. It runs about 2 minutes, so let's see if we can get started. Hopefully you can see that.
It looks good, Greg.
So this area is the Palisades fire, and this was the Eaton fire, a little bit further inland from the coast. Altadena area here, and the Palisades here. You could see the smoke plume well out into the Pacific Ocean here. All of this is smoke. So just an incredible event. The Palisades and the Eaton fire incidents caused destruction rivaling the worst in California history, over 18,000 structures, and the fires rank as the second and third most destructive wildfires in California history, which really is quite remarkable considering the amazing and devastating fire events we've seen in recent years. These two were surpassed only by the 2018 Camp Fire. Estimates of property losses between 76 and $150 billion places this event as probably the costliest natural disaster globally in the year of 2025. Direct fatalities were confirmed around 30 individuals, although researchers estimate hundreds of additional indirect deaths occurred or will occur due to the smoke and health issues related to the smoke. The images on the top show the daily growth of the Palisades fire on the left and the Eaton fire on the right. And you can see how both fires burned for more than a week, but most of the destruction occurred within the first 2 days in the most populated areas. Yellow dots on the map are buildings that were affected or burned by the fires. And then at the bottom is a before after image that shows a typical neighborhood, what we saw in the Palisades as well as Altadena, total loss of residential homes and other buildings in areas with the yellow dots again on the maps above. So an incredibly devastating event to start out 2025. We'll move on to memory number two. Historic snowstorm transformed the northern Gulf Coast into a winter wonderland on January 21st, 2025. The snowstorm shattered long-standing snowfall records across the region, including a nearly 130-year-old snowfall record that was set during a February snowstorm in 1895. The Pensacola Beach water tower is barely visible barely visible in the image on the left there, and you can see the watches and warnings evolving across the Gulf Coast. The winter storm watches essentially in that magenta pink color there. And at the top, the beaches are typically white sand, but that's snow right on the Gulf Coast beaches in Alabama. So the warnings for this event were pretty well out ahead of it, about 4 days in advance, but it is really tricky forecasting accumulating snow right on the Gulf Coast like this. I'm going to take a look at the evolution of the upper air pattern here and the radar. So this is a 2-day radar loop from late in the day on January 20th through late afternoon on the 22nd. It shows a broad shield of snow spreading across the Gulf Coast, coincident with the passage of a relatively innocuous mid-level disturbance shown at the 500 millibar pattern there in the inset loop. This event was driven primarily by strong ascent well to the north of a developing cyclone in the Gulf of Mexico, and the unusually cold air mass was well entrenched across the Gulf Coast before the disturbance developed in the Gulf. And as that development occurred, sufficient moisture was returned north across the surface-based cold air dome to contribute to the heavy snow. This set of circumstances in this part of the country may be a once-in-a-lifetime event. This is not very common at all. And you can see here in the next slide, the day after the storm, as the clouds cleared to the south and east, the visible satellite images showed a remarkable swath of snow, again, in a part of the country that rarely sees this type of event happen. Looking at the snowfall amounts from NOAA's National Center for Environmental Information, these are one-day snowfall records from this storm, and you can see the totals on the right on the Gulf Coast in excess of 8 inches. So just incredible. I cleared about half a foot of snow this morning, and it's still pretty remarkable seeing 6 inches of snow, let alone 8 to 12 inches in some spots. So this was really unusual, and thanks for CoCoRaHS observers for getting out there. They went out into the elements with their rulers. You can see here on this slide, the National Weather Service in Mobile, Alabama, thanked over 60 snow depth reports from the network observers in CoCoRaHS. And you see the max 2-day snowfall total for Mobile there, the table on the left, and then the max 2-day snowfall total records for Pensacola. Both of these events setting a new record. The prior record all the way back in 1895. So perhaps a once-in-a-lifetime event for folks on the Gulf Coast. If it's going to happen, it's probably going to happen in January. So that's when they saw that. Okay, we'll move on to memory number 3. And this is going to divert a little bit from meteorology, but I do want to talk about the passing of a remarkable man and former colleague, Dr. Charles A. Doswell III, a renowned meteorologist and severe convective storms expert, passed away at the age of 79 at the end of January 2025 in Norman, Oklahoma. He was a neighbor of mine when I lived in Norman, and from an excellent obituary written by Dr. David Schultz, those who met Chuck never forgot the experience. He was hard-nosed and rigorous, unafraid to challenge any status quo and to call out any nonsense. He trained and mentored students, forecasters, and researchers worldwide, imparting to them the need for scientific excellence and clear, precise communication. And here he is in a field of wildflowers, likely in Oklahoma, enjoying a fine red wine and sharing some of his wisdom. It's a wonderful shot of Chuck in his element there. And the next slide, I'd go into a little more detail. I was lucky enough to know and work with Chuck during my years as a forecaster and outreach meteorologist at the Storm Prediction Center. He is a prolific writer of formal and informal papers and posts. I learned a lot from him, and I enjoyed his visits to the center during the late 90s and into the 2000s. Here's a small review of some of Chuck's more impressive work on severe storms, especially tornadoes, but also microburst identification and flash flood forecasting. I was fortunate to be a co-author with Chuck and fellow research meteorologist Dr. Harold Brooks on a historic perspective of the tornadoes of spring 2011 that it subsequently was published by the Royal Journal of Meteorology. To have my name on a formal manuscript byline with Chuck's was one of the high points of my career. He was a giant of modern meteorology, made substantial contributions to the science, and he will be missed. And the listing here just shows you the publications that Chuck's most likely been the lead author on across many, many formal journals from the American Meteorological Society. And he was just an amazing scientist, very insightful, and just, I would say, a genius in terms of his ability to understand the atmosphere and the math associated with that. Another departure here, sticking with the non-weather event, but meteorologically relevant topic. My memory number 4 is a look at the disturbing politically motivated attacks we've all witnessed on NOAA, the National Weather Service, and science in general. Of course, the rise of AI is another topic, but these two images were generated by prompting AI with some of the headlines we've seen in 2025. They're disturbing. And while I departed from government service in 2024, I remain connected to friends and colleagues who continue to show incredible dedication under enormous stress. It doesn't have to be this way. And however this grave damage has already occurred, I don't understand why. I don't fully understand. What I do know is that we can speak out and contribute to a greater understanding of the benefits of the physical sciences to our society. The advances and the applications in meteorology alone would not have been possible without government funding and support. From more accurate forecasts and warnings to technological advances in computing and data science, we all benefit from very reasonable investments in tax dollars. The direction this current administration has taken in wielding a very coarse budgetary axe across many areas of science will not end well and is not in the best interest of a great society. Perhaps a presentation such as this one is not the place for such political speech, but I wanted to point it out. Just like you volunteer and we have cooperative observations for rain and snow and contribute to a better understanding of the weather, so too does collective action and awareness make a difference. And perhaps we still have time to turn this series of unfortunate events around when we make our voices heard at the ballot box and in talking sensibly to each other. Okay, off my soapbox for now. We'll get back to weather events and for the rest of the talk, I promise. Memory number 5, from March 13th to the 16th, 2025, a widespread and deadly tornado outbreak, and the largest on record for the month of March, affected much of the Midwest and Eastern United States, with additional severe weather and impacts on the East Coast. The SPC first issued a moderate risk for severe weather for parts of the Midwest and Southeast on the 14th of March, as a large upper-level trough moved west over the Rockies. The Day 2 outlook was upgraded to a tornado-driven high risk for portions of the Mississippi and Alabama areas, making it the third ever issuance of a Day 2 high risk. So pretty unusual to have that level of confidence 2 days in advance of a significant outbreak. The previous two outbreaks were April 7th, previous two moderate risks on the Day 2 outlook were April 7th, 2006 and April 14th, 2012. These maps show the severe weather outlooks for both days, sort of a composite of the 2-day event, as well as warning polygons and tornado events shown there, tornado warnings, and the deadly tornado icons are shown as small red crosses on the map. They're kind of hard to see, but you can see where some of the killer tornadoes occur. The photos on the right include the photo of an EF3 rated tornado near Bakersfield in southern Missouri, and damage in a mobile home park east of Bakersfield, where 3 people were killed by the tornado. Looking at the 2-day event, these are the Storm Prediction Center storm reports, the blue dots being wind reports, the red, the tornado reports, and the green hail reports. Some of the darker squares there are significant wind gusts just to the north of the tornado tracks, which primarily occurred across Missouri, and northeast Arkansas into the lower Ohio Valley. I'm going to mute for a minute so I can just clear my speech. There were at least 44 fatalities associated with this outbreak, 24 of which were directly related to tornadoes. And this may be one of the costliest tornado outbreaks of the year, at least 10 billion in reported property damage. The strongest tornado was an EF4 with estimated winds near 190 miles an hour in northeast Arkansas late in the day on March 14th. We're going to take a much deeper dive into the atmospheric environment that allows such an extreme storm to develop in just a bit. But first, just taking a big picture look here at the radar loop, and this goes over 2 days, and it shows how this particular storm system evolved. You can see the cyclone deepening rapidly in the lee of the Rockies over western Kansas on March 14th. And this system draws a tremendous amount of warm, moist air north across the lower Mississippi Valley, while a dry line and cold front sweep east. And the heating of the day further contributes to destabilization. The intense storms erupt in an arc from Missouri to Arkansas during the first day of the event, and then the activity subsides briefly with the loss of daytime heating, but the strong lift associated with the upper jet pivoting around the base of the storm system adds to a resurgence in deep thunderstorms during the second day of the event, March 15th, from northeast Texas across the deep south and the Tennessee Valley. Okay, now we're going to get technical here. What's really interesting, we have a series of upper air soundings. This is a skew-T diagram on the left, and these soundings were all taken at Little Rock during the day on March 14th. Not every severe weather event allows us to look at this information in such detail, but in researching the event, I realized that the Little Rock office of the National Weather Service released 4 upper air soundings on this day, and these storms produce an incredibly intense tornado about 80 miles to the northeast of that upper air location late in the day. So the following slides, I'm going to go through a little bit of detail here on the skew-T diagram, and then we'll look at how the radar basically coincides at the approximate time of the upper air observation. So these are upper air balloons that are launched from Little Rock, and we'll start at the beginning of the day here. So this is 7 a.m. And what we see here is a surface temperature in the low 60s. Moisture is not particularly impressive. The dew point at the surface is 54. The green line is moisture in the atmosphere all the way up above, well above the jet stream. And the red line depicts the temperature out in the atmosphere. And so what we see here is what we call an inversion, which is not unusual. At night, the surface temperatures cool off, but they stay warmer just above the surface. And this inversion tends to inhibit strong thunderstorm development. We call it the capping inversion. If you read the discussions, you'll hear capping inversion or elimination of the cap as a strong ascent and heating of the day. So you can almost imagine as you heat the surface temperature up, how that inversion or that warmer air aloft basically is erased. And then you start to see buoyancy, and you have air parcels that are warmer than their surroundings, so they want to rise. And then you'll see the wind field here and these wind barbs in the morning, relatively light wind shear, generally a southwesterly flow, these barbs pointing in the direction of the wind, where the wind is going. We could spend all day on the skew-T, but I just want to look at the evolution. So this is the early morning. We're going to move now to 2 p.m. in the afternoon, and I can actually switch back and forth. We can see how that sounding changes during a period of several hours from morning to afternoon. The inversion, interestingly enough, has actually risen in the atmosphere. It's gone up, but it's still quite evident here. You see this typical, what we call the capping inversion. And the other aspect of the sounding is what we call steep lapse rates. In other words, it's much cooler aloft than it is down here a few thousand feet above the surface. And you can see if you could get an air parcel to rise above this inversion, this dashed line is kind of the typical path that parcel would take. And this is positive buoyancy in the atmosphere. The wind fields have very much increased over this period of time. We're now at 2 in the afternoon. What's interesting on the radar on the right here is you can see a few scattered thunderstorms have developed east of Little Rock near the Mississippi River, but the stronger system is coming out over Oklahoma and Kansas. These storms that are to the east are probably occurring above this capping inversion. They're probably high base, what we call high base thunderstorms, and they're not typically going to produce severe wind or tornadoes at the surface because they're not surface based. They can produce hail in an environment of strong shear, and it's possible a few of these had some small hail. But now forecasters are looking at, okay, how long is it until we see the elimination of this capping inversion in the sounding and the realization of the shear through a deep layer of the atmosphere? The shear is already very strong and supportive of severe storms, but this capping inversion will prohibit surface-based storm development until it's eliminated. And as you rise, as the air rises in the atmosphere, it cools, and as you get heating of the day at the surface, you also have a tendency to eliminate these inversions. So let's see what happens next. This is 4 p.m., and that inversion is almost gone now. And we see that the low-level wind fields have backed. The wind is very strong through a deep layer of the atmosphere. The instability is very high here. Temperature now up to 70. The moisture's increased dramatically here late in the afternoon. And we start to see the intense ascent or lift with the cyclone coming out of northeast Oklahoma into Missouri. So this environment with this sounding representing the air mass that's situated over Arkansas is just a very classic supercell sounding, supercell tornado sounding. So with the inversion eliminated and these intense thunderstorms coming in, we've got some real challenges ahead. There's one more sounding to look at here by 7 p.m. This is a classic tornadic supercell upper air sounding out of Little Rock. And there's no more inversion. Air parcels are dramatically buoyant from very close to the surface, and those parcels will rise rapidly in a wind environment characterized by strong shear. The radar is ominous, and the stronger storms in this image are rotating, and some already have tornadoes associated with them. This very quick review of the soundings helps us better understand the dynamics of severe storms, and because of the work of the upper air team at Little Rock, this case lent itself well to this type of analysis and was quite memorable. And we're going to continue with this case a little bit longer. I'm going to show a storm following satellite loop here that's really remarkable. Over the 2 days, you see the system evolve across the southern plains. I may play it one more time here because you'll see a lot of dust that comes across parts of Oklahoma and Texas here. There were also wildfires and dust associated with this event. And then it moves basically up into the upper Midwest, but the strong thunderstorms persist all the way off the East Coast over the 2-day period. Just a snapshot here showing this dust. This is all dust streaming out of eastern New Mexico across Texas and into Oklahoma. There were deadly wildfires in northwest Oklahoma with this. This is a picture of the dust that created a problem with respect to traffic visibility on some of the highways out there. The wildfires were, again, an aspect of the wind and dry air behind the storm system. The system caused at least 44 fatalities, about $10 billion in economic damage. And we're not done yet. On the cold side of the cyclone, a winter storm named Nyla by the Weather Channel also produced significant impacts. Notably, a strong blizzard occurred across the high plains and Midwest where winter weather and blizzard warnings were issued. So quite a memorable event for memory number 5. On to number 6, memory 6, a challenging forecast for this event, and this happens when abundant tropical moisture is in place, but the forcing for lift is either weak or ill-defined. Strong to intense thunderstorms developing in these environments can create their own smaller scale circulations that contribute to thunderstorm persistence. And given the magnitude and the moisture of the warm air in place, the rainfall process becomes almost supercharged and very efficient. So this is an example of that type of an event, and unfortunately, this was not the only extreme rainfall event to impact Texas in 2025. We'll take a look at the radar here across the lower Rio Grande Valley, and you can see it doesn't look particularly organized, but toward the end of the loop, you can get the sense of the cyclonic mid-level system that aided deep layer ascent across the moist air mass. Well, this weak circulation was evident in the analysis data ahead of the heavy rainfall. It was more than likely enhanced by the deep thunderstorm activity over time, a kind of positive feedback loop that can be extremely difficult to predict ahead of time. At least 6 people died during this event. One confirmed fatality involved a vehicle plunging into a submerged canal in the blinding rain. And this slide shows the rainfall for the first 24 hours of the event with some 1-day precipitation total records there at the Rio Grande International Airport in Harlingen. a foot plus of rainfall from March 26th to 27th, exceeded the previous record by nearly 3 inches. It's also interesting to note how a number of these top one day rainfall events have occurred just recently in the 2000s, in a record that extends back over 70 years. And looking at the 2-day totals here across South Texas, they're simply stunning for an area that does not drain very quickly either. Harlingen ultimately recorded around 20 inches of rain, something you might expect with a tropical storm, but this had tropical air mass associated with it, but it was not a tropical cyclone. This broke the all-time daily 2-day record that was set in 1912, and the Arroyo Colorado River crested at 30.44 feet, smashing the previous record of 24 feet set during Hurricane Alex, and flooding that occurred from Alex in 2010. Reports suggest the damage and recovery totals from the flood would likely exceed $100 million, according to the National Weather Service in Brownsville. And we're going to stick with the flooding theme here for memory number 7. Starts with multiple rounds of heavy springtime rain and thunderstorms that impacted the lower Ohio Valley from April 1st through the 6th of 2025. The first significant wave consisted of severe thunderstorms producing several tornadoes during the afternoon and evening on April 2nd. Flash flooding became a greater concern during the overnight as storms trained over the same locations over the next few days. So waves of showers and storms rode along the frontal boundary, bringing torrential rain that led to widespread flooding. Heavy showers and storms came through daily until the evening of April 6th. The resultant flooding turned into historic and near record-breaking river flooding along many river basins. And I've got a loop here showing the composite radar and satellite data along with surface pressure from April 4th through the 5th. And you can see those waves traveling along that front. This is also aided by an atmospheric river we're going to look at next, a water vapor, a deep tropical water vapor coming off the Caribbean and the tropics. And it was already saturated. The ground was very saturated from late winter rainfall, leading to immediate runoff and flash flooding. There was also a lot of severe weather with this. On April 5th, the high risk for severe storms issued by SPC. And the weather prediction also issued a high risk of excessive rainfall and flash flooding for this event. So the bigger picture look here, you can see the extended loop of atmospheric water vapor showing how the deep moisture plume with origins in the tropics was brought northward into that frontal zone draped across the Mid-South. And anything in excess of anything in here green to yellow is deep moisture, 1.5 to 2 inches of what we call precipitable water streaming into that area. And you can see its origins down here deep in the tropics. At Memphis, 5.47 inches of rain on April 5th was the wettest April day on record. The 5-day total of 12.35 inches was the third highest in the city's history, dating back to 1872. And there were a number of record crests or near record crests on rivers across the region. The Kentucky River at Frankfort crested at 48.27 feet, just short of an all-time record set in 1978. The map depicts the total rainfall accumulating over 3 days, with the areas of 10 inches or more highlighted by the black outlines. This 3-day rainfall total in this location has a recurrence interval of about once in 100 years, or a 1% chance of happening in any year. And here's the event summary graphic from the Weather Prediction Center for this historic April rainfall event. The image shows the 4-day or 96-hour rainfall totals and the extent of the moderate to major river flooding across this area. At least 24 people died during the multi-day event, which also included reports of at least 150 tornadoes. 15 deaths were attributed to non-tornadic activity, primarily flooding. Thousands were evacuated from towns like Falmouth, Butler, Kentucky, and Shelbyville, Indiana. In Kentucky alone, approximately 540 roadways were closed due to high water, and preliminary estimates placed the total economic losses between $80 and $90 billion for this event. Okay, we're on to memory number 8. A deadly and destructive tornado outbreak spawned more than 60 tornadoes in portions of the Midwest and Southeast United States from May 15th to 16th. The event occurred as a negatively tilted trough, a progressive but very dynamic upper trough moved into the upper Midwest. And the SPC first issued an enhanced risk on May 15th for portions of the Great Lakes. Several tornadoes, mostly weak, touched down that day across Wisconsin and Minnesota as embedded storms within the squall line moved through, causing damaging wind gusts. And this image was taken from the St. Louis Gateway Arch on the afternoon of May 16th. I don't know if I would have wanted been in there, and I hope those people got out very quickly, given what was coming into the metropolitan area of St. Louis. Here's a look at the evolution of the Storm Prediction Center severe weather outlooks from about 1 week ahead through May 16th. So it's a 2-day event here. So we're looking at the outlooks. All the outlooks are valid for May 15th on the left and May 16th on the right. And you can see how the forecast refines over time. And then the very last image shows the resulting severe weather reports as well with the forecast. So this event, again, began with some discrete supercells in Minnesota, Wisconsin, and the instability helped produce hail up to 4 inches in diameter and 15 tornadoes in Wisconsin, along with the straight line wind gusts, about 100 mile an hour in some of those wind gusts. By May 16th, you can see the Storm Prediction Center issued a moderate risk as the storm system moved southeast and the atmosphere became volatile with mixed layer Cape instability values very high, 3,000 to 4,000 joules per kilogram. The deep layer wind shear of 65 to 70 knots certainly helped produce widespread organized severe storms. I'm going to focus on a couple of the tornadoes in this event, the first one being the one that moved through St. Louis. So after an extensive damage survey lasting several days in consultation with tornado damage experts, the Weather Service office in St. Louis rated the tornado an EF3 with peak winds of 152 miles an hour. Again, that's the one we saw moving into St. Louis from the Gateway Arch. It damaged or destroyed thousands of buildings and caused over $1.6 billion in damage in the city of St. Louis alone. One person also died in a neighborhood south of St. Louis when a tree fell onto their truck. A few pictures along the damage path in the courtesy of St. Louis office of the Weather Service include broken trees in the neighborhood there and a destroyed steeple of the North St. Louis Church. This is not the first tornado to hit St. Louis, nor is it the first to result in fatalities. But that said, the last tornado-related death to occur in the city of St. Louis proper was in 1959 when an EF4 tornado claimed 21 lives and injured hundreds. The other tornado I want to focus on occurred later in the day and into the evening on May 16th. It was a particularly long-lived supercell that tracked east from the Ozarks of southern Missouri, intermittently producing brief tornadoes and wind damage as it moved through southern portions of the western and central Kentucky. This supercell's most destructive tornado touched down about 4 miles southeast of Russell Springs, Kentucky. The damage path is fairly narrow as it tracked through southeast Russell County and into Pulaski County, causing significant damage to structures and trees, later strengthened and widened, achieving EF4 damage and estimated winds around 170 miles an hour as it moved toward Mount Victory, Kentucky. The tornado's path of devastation continued eastward through the rugged and forested terrain of the Daniel Boone National Forest. And you can see that in the upper left satellite image there a couple of weeks later, showing the damage to the trees. And the width of the tornado at this point was about 1,700 yards in width. Radar indicated that debris was lofted at least 27,000 feet above the ground. And the tornado narrowed again as it approached and crossed I-75, scouring neighborhoods south of downtown London, Kentucky. The ASOS system at the London, Kentucky airport just before going offline reported a peak wind gust of 114 miles an hour. So the tornado has basically gone right across the airport there. And you can see the damage that resulted in the London area at the picture in on the right. There's another aspect of this storm that was pretty remarkable. The intensity was with the wind fields associated with the storm system, brought a rare dust storm that enveloped the city of Chicago just ahead of the cold frontal passage late on the day on May 16th. And you can see the satellite imagery with the dust coming off the fields of eastern central Illinois and being brought northward into the metropolitan area. And that's a remarkable picture that I found on someone on Instagram posted. I think it's real. That was the dust coming into the city. And the reason I think it's real is if you look at the satellite image, there's certainly a wall of dust that moves in while they still have daylight there. So reminds me of some days in Oklahoma, but it's very unusual to see that happen in Chicago. On to memory number 9, and we all probably remember this one. On July 4th, leading up to July 4th, 2025, destructive and deadly flooding took place in the hill country region of Texas. During the flooding, water levels along the Guadalupe River rose rapidly. As a result, nearly 140 people lost their lives, at least 117 of them in Kerr County, Texas. The flooding was caused by a mesoscale convective vortex with enhanced tropical moisture. Next few slides I'm going to go through here will be featured on a YouTube video, and I'll tell you how to get to that with a forensic analysis. But just to get our bearings here, this map shows the area around Kerrville, about 60 miles northwest of San Antonio, and that was the most impacted by the incredibly intense rainfall. And I'm going to show a radar loop here that basically shows the rather disorganized structure of the storms, but again, that sort of positive feedback loop that occurs to sustain deep convection in certain environments like this. So this is the entire event over west central Texas, and the Kerrville, Texas area is up in here. And initially, you kind of see this circulation, and then what happens is the storms generate a sufficient cold pool at the surface, which eventually helps move the updrafts out of the area that they've persisted in for quite some time. Very, very difficult to forecast the evolution of this type of event. There may be signals in some model data, but getting the exact location of some of these events is incredibly challenging in the forecast. And so we're going to go into a little more detail here on this one. There's the YouTube link, but if you just search for Camp Mystic flood analysis, there's an excellent forensic review of what happened over the South Guadalupe River Basin, which is outlined in red on this map here. Again, about 60 miles northwest of San Antonio's here. South Guadalupe River Basin is highlighted in red. We'll zoom in a little bit here. Camp Mystic is basically right where the star is in this image here. So most of the rainfall that falls over this basin is just going to come downstream the South Guadalupe River. And there's also a gauge not far from here where the river comes into the Guadalupe. But we'll just focus on this particular basin here. And this YouTube video goes into depth about the rainfall that falls. And I'm going to try to give it some justice here, just using the information from that video. So over a period of about 5 hours, 5 to 10 inches of rainfall fell over this basin. And the color here is the rainfall. About 9, almost 10 inches of rain here upstream from Camp Mystic. And this is over a very short period of time. And you can see that in the following graph that we go to here. The curve shows the rainfall rate and how the rainfall accumulated. So basically, in the first few hours in the evening, three inches in about 2 hours for a total of about 3 inches over the basin. And then 6 inches in 2 hours, just absolutely torrential tropical rainfall downpours for a total of 9+ inches in about 5 hours. And of course, the result on the river is shown here. And you can see you basically went from a trickle. This is a graph of the CFS, or cubic feet per second, estimated in the South Guadalupe River, going from a trickle, basically a stream you could walk across, to the force of Niagara Falls over a very short period of time, less than 6 hours, and unfortunately at night. So really the combination of the worst conditions possible for an extreme flash flood in an area that is not unused to this. This area does see these events occur every few decades, and unfortunately this was another one that happened to occur on a holiday weekend when many people were in the basin, including the unfortunate campers at Camp Mystic. The satellite image here shows the mid-level low pressure system, or what's called a mesoscale convective vortex, stalled against the Balcones escarpment, which acted as a physical wall, forcing moisture upward and anchoring the intense storms. Again, rainfall rates 3 to 5 inches an hour and transformed the Guadalupe River into a wall of water. The consequences were obviously devastating. The death toll from this unfortunate flash flood event was the highest for a flash flood of this character in nearly 50 years. The Big Thompson Canyon flash flood of July 1976 is probably the most recent flash flood event to exceed the death toll in this tragic Texas flood. Finally, for 2025, we're going to end with a very rare event outside of the contiguous United States. The remnants of Typhoon Halong devastated Alaska's Yukon-Kuskokwim Delta on October 12, 2025, bringing hurricane-force winds of up to 107 miles an hour and a record-breaking storm surge that swept entire homes, some with families still inside, off their foundations. Remarkably, there's really only one fatality confirmed, but there's some remaining missing immediately after the event. But over 1,600 residents from remote communities had to be evacuated in one of Alaska's largest airlifts in recent history. The map on the left shows the track of how long as it moved north across the Aleutian Island chain and then dissipated across Western Canada as an intense low pressure system. Alaska Governor Dunleavy, in his request for federal disaster declaration on October 16th, said that many residents will not be able to return to their communities for many, many months, perhaps over a year. The Red Cross asked for OpenStreetMap to help map the villages that were damaged by the storm as they began operating in the area. 1,000 emergency meals were also distributed along the coast. On October 22nd, the president approved Alaska's disaster declaration. As part of the approval process, the federal government said it would pay for all disaster-related expenses for 90 days. And according to the Alaska Village Council presidents, 52 communities reported damage, with about a dozen reporting significant damage. And Department of Homeland Security reported 208 homes are totally destroyed, 471 sustained major damage. And this is just a picture well inland from Norton Sound, where the water just was brought well inland. Here's a picture here showing how unusually low the surface pressure was with this decaying tropical cyclone. Essentially, no October storm system had reached pressure that low, and as the system did on October 12th. And the intense circulation around the low pressure is shown on the right, with the wind gusts likely exceeding 100 miles an hour, streaming across Norton Sound and pushing that water from the sound well inland, resulting in devastation to local communities, a rare and unfortunate weather extreme for this remote part of Western Alaska. And that concludes today's presentation of the 2025 Meteorological Memories. I hope you enjoyed the talk, and I appreciate the attention that you've given. And again, thanks to CoCoRaHS for the invitation. And I think we might have a bit of time for some questions. So I'll pass it back.
Yeah, Greg, thanks. And I really appreciate this. You know, as you were talking about the halogen event, I just realized I was down there giving a talk down at Brownsville the next day, and I've got a short video here, 10 seconds, if you don't mind me
Sure.
sharing my
Sure.
screen. Let's see. So you need to stop the share and let's see, can I get it now? Here we go. And so I'm going to play this. Can you guys see that?
Oh, yeah. Yep.
Oh, this is a farmer's field.
Yeah.
This is a dry field, and I'm going to put the video on. And it was just like a lake. I could not believe I stopped the car, and the water, almost some whitecaps on there, right by some railroad tracks. But it was amazing to see how much water. Again, that fell. Unfortunately, we only had one CoCoRaHS observer in the area, but definitely something that stood out in my memory from your talk today.
I know the airport was closed for a few days too, I think.
Yeah, I think so. It was quite the event. Okay, we'll come back. Thanks for letting me pop that on there real quick.
Sure.
And do we want to go back to your screen again?
No, we could. Let's see
Why don't we
here.
just leave that up there?
All right.
And folks, I'm going to post the um, URL for the San Antonio, for the Kerrville, the flood there, uh, information or the YouTube thing on the CoCoRaHS website under, so if you go to our Weather Talk page, you'll see the different Weather Talk talks we've had, and this one will be listed on there, and you can click on that and you'll get the URL. Okay, well, it's time for questions, Greg, and let's see. You guys want to type them in? If you have a moment here, we've got a few minutes left, and Greg will come and or we'll be glad to answer those as well. And Chuck Doswell's another guy I remember very well when I worked with AMS at the broadcast conferences. He was quite the quite the character
Oh
sometimes
yeah.
when we would get together. Great
Yeah.
guy, great guy. Anyone? Any questions out there for Greg? Anyone? Bueller? Oh, here we go. Nope. Okay. All right. Well, I yeah, just a lot of excellent reports here. And oh, okay. And number five, here's Mary wanted to know Jonesboro was reporting anticyclonic storms. Please explain. Um,
Occasionally, you do see anticyclonic rotation in thunderstorms and supercells. It's usually associated with what we call splitting storm. Usually the right hand side of an updraft is favored for cyclonic rotation, but occasionally under the right wind direction and shear, you can get a storm to split, and in the northern portion of that supercell can take on anticyclonic rotation. And it's really related to the directional shear and the track that the storms are moving in, basically the direction they're moving. But you can see these storm splits. Normally, the northern splits are usually associated with large hail. It's difficult to get tornadoes out of those. It's the right moving supercells that usually produce tornadoes.
Thanks. Here's one from Mia. Mia wants to know, is there a place you could learn how to read a SKU-T? So
Oh,
is
I think so. Nowadays, there's probably resources online. MetEd, if you do a search for MetEd, I think that there are some excellent tutorials, all parts of meteorology available there. And
that's Met as an METED.
yeah,
Yeah, not
MET.
MED. Okay.
Yep, yep.
Great. Okay. We've got a couple more questions on here. Laura's wondering, she says that we seem to be having very strong wind events, 40 to 50 miles an hour in South Dakota. What seems to be causing this lately?
Living in South Dakota. But, I mean, I lived in the plains, and it was not uncommon to have bad hair days. And so, the plains, because of the flat, open terrain, are quite susceptible to winds. I'm not sure, if you're talking about the winter or there've been a number of strong Arctic air masses that have come across, and so I don't know if those winds are associated with larger weather systems and larger pressure gradient associated with cyclones, or if you're talking about thunderstorms. But South Dakota is pretty famous for wind. Maybe it's just more frequently that you've experienced it recently.
Okay, we've got another one here. Rick wants to know, how did the Balcones escarpment affect the storm in event number 9? So
I
I'm not
think
sure.
any time that you're dealing with a change in surface elevation, you have the potential to enhance the atmospheric lift. And so that escarpment is basically a higher area of terrain. You've got warm, moist air that is being driven northwestward or westward into that higher terrain. It enhances the lift in the atmosphere. So it's essentially providing ascent and focused ascent due to the higher terrain of the escarpment.
Charles wants to know, with the cutbacks lately in science, are the soundings being reduced across the country?
Yes, they have been. Luckily, that one case that I was able to show there for the March outbreak, there were enhanced soundings that were requested by the National Weather Service because of the potential for tornadic storms. But a number of stations have gone offline or have gone to one sounding a day. Soundings are expensive, and so they need to be, used judiciously. But yeah, there have been a number of sounding sites that have gone offline due to some of these budget cutbacks and also staffing cutbacks. There have been some tests with auto launched soundings, I believe up in Alaska, but even those systems need maintenance, and you need people who are skilled at repairing these systems. So there have been cutbacks to soundings.
Mary writes, what is the 2011 report you wrote? She says the Smithville tornado passed by us, would like more information. And maybe if you could give me that information, I will post that. So other folks are also asking, will this be available online? So yeah, probably early next week. If again, go to the CoCoRaHS page and then click on Weather Talk and you'll see a list of talks. This will be on here. We'll post that information, those links. We'll also post Greg's slides. You can go through one by one to take a look at that and also this talk. So we'll get that. And Greg, if you could send me that, I'll post that with some of the other things, the Met Ed and so forth, where folks can find that
Sure.
information. Okay, well, let's go for just a couple more here as we're starting to get to the top of the hour. Um, let's see. Let me see if I can find one or two here. So, Marilyn wants to know what, if any, lasting effects, weather effects, are due to the burn area in Southern California.
So my son lives out there, and I'm actually going to go to visit in a couple of weeks here. So it'll be interesting to see. Clearly, the bigger concern immediately following these fires was the health concerns due to poor air quality. But there are also longer term environmental concerns when you think about the potential for toxic chemicals, just even household chemicals that you have in your home. They don't necessarily go away just because the home burns. They're remnant toxic waste. It is a big problem out there. And so, yeah, those are some of the longer term issues related to the fires. Local weather issues, well, there's nothing left to burn in those areas, but we'll see how they've remained rather dry so far this season in the West and very warm. And it's possible that the lack of vegetation in some of these areas can produce what's kind of a feedback loop in terms of drier conditions persisting a little longer than they might otherwise. So, not a good situation.
Okay, we'll take one last question, and then again, Greg will email you guys the questions he hadn't had a chance to cover here during the talk. But here's one from Clark. He wants to know, are severe weather events becoming more common considering climate change? So is there much of an effect that we start to see more severe weather events?
There's been a lot of work on what's called attribution, the relationship of climate change to significant weather events. Perhaps Perhaps one of the more confident things we can say regarding climate change in a warmer climate is that we're likely to see more extreme precipitation events. And we saw that with this past year. It was really not until I started to dig into some of these events that I realized how extreme some of these precipitation events were. But the atmosphere being warmer can basically hold more water vapor. And so the potential exists for greater rainfall amounts from storm events. And as far as severe weather goes, it's a bit tricky. We could see an increase in instability with a warmer atmosphere, but you can also see a potential to remain capped. We talked about the capping inversion and the sounding. So warmer air aloft can sometimes inhibit thunderstorm development, but we have seen perhaps a slight shift in where we see these more intense storms develop and perhaps favored a little bit further north from where they've been in the past. But there's still a lot of research need to be done to provide attribution to specific severe weather events as associated with tornadoes and severe thunderstorms. I think more confidence certainly exists for greater precipitation in a warmer climate.
Well, Greg, thank you for spending this last hour with us. It's always a pleasure to hear your talks, and hopefully we can maybe do another one next year. Again, so thanks a bunch. Folks, as we close out today's program, we want to let you know that our Weather Talk schedule for 2026 is still being finalized. We're still working on that. But if you have any suggestions, if you have, what would you like to hear? Again, if you look at our list, we've covered soup to nuts on these from, I think we've got about 95 of them in the books now. And so let us know if there's anything you might be interested in, and we might be able to find an expert to talk on that. So we'll get the schedule out here. We'll post it later excuse me, post the details on our website soon. Hey, before I forget, when signing off today, please complete the survey that you're going to see on your screen here shortly. And until we meet again, this is Henry Regis for the rest of the CoCoRaHS team signing off for now. Take care.
Thank you, Henry. Happy New Year.
Same to you, Greg.